The topic of my talk is optimal consumption portfolio strategy and housing choice problem with a loan-to-value ratio. The LTV ratios are how lenders describe the amount you need to borrow to buy a property. For example, your lender values the property at $500,000, but you only have a $150,000 deposit. That means you need to borrow $315,000 to buy the house. So the loan-to-value ratio will be calculated as 17%. The mortgage interest rate is what it costs you each month to finance your property. In the model, we consider two underlying assets. One is risk-free asset, such as a bond. The other is a risky asset, such as a stock. The wealth per size can be formulated as this stochastic differential equation. This term is the rental cost, and this term is the mortgage interest. We apply the form of Cobb-Douglas utility function. So the problem in this model can be formulated as this equation. This is the value function. The objective of the agent is to maximize the expected utility from lifetime consumption and housing by choosing consumption rate, portfolio per size, and the housing rate. These are closed-form solutions to the above problem. We also did the numerical demonstrations according to the solutions based on the parameter citing. According to these are the comparison with the benchmark model. In the benchmark model, we don't consider a loan-to-value ratio. So according to the results, we can see an agent who has an opportunity to borrow money from a bank will purchase a larger house and delay the time to buy a house. At the same time, the consumption and the investment will rise than an agent who doesn't have an opportunity to borrow money from a bank. From these figures, we can see a larger LTV ratio will result in more consumption, a less investment, and a larger purchased house. At the same time, the agent will also delay the time to buy a house with a larger LTV ratio. These are some of our references used in this paper. Thank you for your attention.